Okay, this is a percentage yield question, but it's tackled in very much the same way as all the other questions that we've done, where we've been given the mass of one substance. So in this case, we've been given the mass of iron oxide, and there's the formula there in the equation. So we've been given mass in grams, and it looks like it's mentioning two more things in the question, but actually it says excess of carbon monoxide. So excess of carbon monoxide means that there's like loads of it there, and there's enough of it to react with all of the iron 3 oxide. So there's not like going to be anything left over. All the iron oxide should react. So we can kind of ignore carbon monoxide. But we have been given, this is what makes it look confusing, we've been given a mass of iron. And so it sort of looks like we've already had the question answered, because usually in the other questions, the question says, here's the mass of iron 3 oxide, what mass of iron is produced? But it's then asking, what is the percentage yield? So what the percentage yield is it's like any kind of percentage. The percentage, like out of a test, if you were doing a test, your percentage would be calculated by the marks you got divided by the total marks that you could have, like the maximum number of marks there were on the test, and then you times by 100. So in a chemical reaction, we get our percentage yield from the mass that is actually obtained. And there's many reasons why you might not get all of the mass obtained in a chemical reaction, just like there's many reasons why you might not, get all the marks on a test. So it could be that some of it went missing in the process, it could be that it didn't fully react, maybe it didn't get hot enough, all sorts of things. Or maybe when you tried to sort of purify the products, maybe you did some filtering or something else and you lost some bits along the way. So you never quite get all of your pure product out as much as you'd like to. So when a percentage yield question comes along, it's telling you that you didn't get all of your iron 3 oxide turned into iron. And so the percentage is the mass that you actually got divided by, just like our situation with our test, the maximum mass that is possible. And because it's a percentage, we times it by 100. Okay, so what we need to work out, we've actually got one of these things already. Mass actually obtained is here. That says it's produced. So that already goes in that part of the equation. So what I need to work out is this thing on the bottom, and that's going to be the case for pretty much any percentage yield question. I need to work out what is the maximum mass possible. So I do that just like I do any other mole calculation. I've got mass in grams of iron oxide. So I can do a mole calculation to work out the moles of Fe2O3. I've got mass in grams, it's 1,000 grams, and the mass of 1 mole, I'm going to add up my 2 irons, which is 56 times 2, and my 3 oxygens, which is 3 times 16. Add that all up, comes to 160. So I do 1,000 divided by 160, and I get my answer as being 6.25 moles. Okay, just like all the other questions, I've got moles of Fe2O3, so that's that there in the equation, but I'm looking at the yield of iron, and that's there in the equation. So from that, I need to use the balanced equation, and I can see that I get 2 moles of iron for every 1 mole of iron 3 oxide. So therefore, my moles of Fe is going to be 6.25, that's the moles of my iron oxide, times 2, because I get 2 out, because there's 2 there in the formula for a start. So I times that by 2, and I get my answers. 12.5 moles. Once I have moles, it's super easy to get my maths in grams. It's going to be 12.5, my number of moles, times by the mass of 1 mole of iron. I look on the periodic table where I've already got it here. It's 56. Notice I'm not timesing by 2 again. I times by 2 here. I've accounted the fact that one of those makes 2 of those. So all I need to do now is do that 12.5 times 56. And it tells me that 700 grams is my maximum mass possible. This is a good thing. This is what I want to see in a percentage yield question. Gives me a clue that I've got it right, that the actual mass I got out is less than the maximum possible mass that I could make, because this is my maximum number. If you were doing a test, you couldn't have scored more here than the total number of marks possible. And so in these calculations, I shouldn't be making more mass, or I shouldn't have produced more mass up here than my maximum mass possible. If you do get that and you run out of time, put it in the equation anyway. What you shouldn't do is flip the numbers around just to try and make it less than 100%, because actually you lose both your marks then, because you won't do it like the right way round. So my final percentage calculation, my percentage yield, is going to be, there's my mass that I actually got, 546. There's my total maximum mass, which I worked out because I knew how many grams of iron oxide I was using. I times that by 100 as well, put that all in the calculator, and I get myself 78% yield. Seems very plausible because it's the right answer.